Hello, Science 30. This is our next lesson for the physics unit. Hopefully, yesterday you watched through my notes as well as those crash course videos. And again, I don't have it open, but the crash course video, I think it was number 28. I had put it in for today. It's definitely really good to watch because it's a review of the stuff yesterday. So it's bringing in that Ohm's law stuff, looking at the relationship between voltage, resistance, and current, and that formula that we looked at. I think it was, I'm pretty sure it was number 28. So I think today I had the physics crash course 28 and 30. You probably could watch 29 because I think we will talk about alternating versus direct current today. So you probably might want to watch that one too. I know we're watching a lot of video stuff, but again, without demos and without something where we can really visualize it, it's really, this unit does require seeing things a couple of times and kind of watching some of these videos multiple times in order to get an understanding. I think the crash course number 28 will be really good to review now that you've done some practice with Ohm's law. Please also make sure that you checked through your answer for those Ohm's law practice questions. It's in the, I can scroll slowly, but it's in that key that I actually sent you guys earlier or sometime last week. So these are all the answers for it. I see now that I have some that don't have significant digits, so I slap my own hand. This one is not right for significant digits. This one's not right for significant digits. Hopefully you did better than me. I don't remember if I changed this to 5.0 in yours. So I did bad with significant digits, but you guys are good at that. So today we're going to talk about electricity and kind of circuitry stuff. And I think circuitry stuff, I don't remember if it comes up in grade 7 or grade 8. So some of this stuff is going to be review and some of this stuff is going to be new. I think actually you also do circuits in science in grade 4 as well in a really kind of basic way. But I don't remember anything from grade 4 because that was 1,000,000 years ago. I'm assuming you guys probably don't either. So again, when we're talking about electricity, we're just talking about the flow of electric charge. Again, we're talking about electrons, the flow of electrons within what we're going to call a circuit. Oh, SpaghettiOs. Why won't it let me write? Nothing? Oh, maybe because I'm not in tablet mode. Let's flip my computer. Something every day, right? Something every day has got to not work. Oh, jeez Louise. Okay, it looks like it wants to be a friend. But now where was I? Nope. Okay. So we've done all of this stuff. I said check over the answers. So electricity and circuits. So again, the flow of electric charge. So any continuous set of conductors, so we talked about conductors yesterday. Conductors are things that allow flow of electricity. So any continuous set of conductors is called a circuit. And there's a bonus I in there that you won't really think is there. Circuit. So current will flow through a circuit if it contains a source of electrical potential energy. So hopefully you're thinking another word as I'm writing this. So thinking back to yesterday, electrical potential energy is related to voltage. So electrical potential energy is related to voltage. So voltage is equal to your electrical potential energy divided by the charge. So this is not directly your voltage, but we talked about it yesterday that our voltage is equal to the amount of electrical potential energy divided by the charge. So that a volt is equal to 1 joule per coulomb. And current will flow through a circuit if it forms a closed loop between the positive and negative terminals of battery or the cell. So I'm going to actually pull this up because it's probably easier than me trying to draw and write it all. These are some of the schematics that we'll see with some of the diagrams. So I might not sit as long as you might want, so you might want to pause some of this stuff if I'm going too fast. So a cell, sometimes we'll see it as a DC power supply, so we'll talk about direct current a little bit later today. What it looks like is kind of no, it will not let me write. I still think it won't let me do this. So kind of a longer line and a shorter line, and the longer line is representing the positive terminal. When we're talking about circuits, so electrons will flow from the negative terminal of the battery to the positive terminal, with the negative terminal being the source of electrons. So where electrons are moving from, and they're going to be attracted towards the positive terminal of the battery. So a cell supplies electrical energy to a circuit in the form of a direct current. A battery is lining up multiple cells in a row. So a group of cells connected to supply a circuit with electrical energy. So you can have multiple C's. Yeah, there's the long line, short line, long line, short line, long line, short line. So those are all cells lined up to form a battery. And so those of you that took Science 20, you're going to be starting to think about this because we talked about electrochemical cells in Science 20. So thinking way back for some of you and thinking last semester for others of you, we talked about electrochemical cells as voltaic cells. And so that's where we forced spontaneous redox reaction, which generated the flow of electrons through an external circuit. Sorry, I'm going to cough. It's not COVID, I promise. So the next kind of schematic that we'll have somewhere is a bulb or a lamp. So usually when you're hooking up a circuit, you want a way to determine that electricity is flowing through the circuit. So you might hook up a lamp, and then when it lights up, you know that you have that current running through the circuit. So I don't know how to describe what that is, but it's a circle, and apparently that looks like a light bulb in the center. So it converts electrical energy into light energy. Sometimes you'll see a switch. And so a switch it can be open and then it can be closed. So when it's closed, again, the line will be across here instead, and that allows the closed loop to be created, which will allow current to flow through. So it can prevent current from flowing through when it's opened, and it can be put together, which allows current to flow through. So we just use lines to indicate wires. Again, they need to be conductors, so we can't use anything that is a non-conductor because it won't allow that flow of electrons. So sometimes when we have a connection, a wire off another wire, it'll just kind of looks like a T here. You guys will see this as we go. So a resistor is any device that hinders the flow of electrons, and it resists the flow of the electric current. So it kind of is just represented as zigzags there. So it's resisting that movement of electrons, and we'll see what that actually looks like with kind of our Explore Learning gizmo. Just give me a second. So something like a light bulb is also a resistor. So the internal part of a light bulb will actually resist the flow of electrons, and that resistance is what will allow it to light up. And then we have our devices that measure different components within the circuit. So we'll look at a voltmeter, an ammeter, and an ohm meter. So we didn't really talk about an ohm meter the other day, but that again is measuring the amount of resistance. So some of this stuff, so looking at our connection for voltmeters and ammeters, there are some specific ways that you need to hook them up. And did we talk about that yesterday? I think we did. So yes, a voltmeter needs to be connected in parallel across the device, and an ammeter needs to be connected in series. And we haven't really talked about what those two things mean, but I know in one of the crash courses, it might be the second one, so 30, she talks a lot about why they need to be connected in that particular way in order to make an accurate measurement of the voltage or the electric current within it. Okay, that's probably all I need that for. Let's see if it still works. Good. So sorry, you can go back and pause the video if I've gone too fast there. So there are two kinds of circuits. Sorry, I just see that I wrote myself a note when we were talking about batteries on that last page. So, so you would have seen, so for the first one, again, I had it as a 1.5 volt battery, or 1.5 volt cell, and then I had a 6 volt battery. So remember that each of these little components within it, each of the cells, represent an electrochemical cell. And the way that we figure out the voltage of it, so this is a kind of good example, that it is 4 1.5 volt cells. So the overall voltage of it is equal to the sum, meaning addition, of each of those individual cell voltages will give us our overall voltage of the battery. So the amount of electrical potential that it is able to supply. Back down. So series circuits. So series circuits, what happens within this is current travels along a single path. So it doesn't have multiple routes that it can go. And electrical devices are connected one after the other. So it's got a single loop of conductors. And so electricity, those electrons are flowing in just one direction. They don't take multiple paths. They don't split up or anything like that. They'll go in the same way. So the same amount of current goes through each part of the series circuit. I guess I could draw a little star there. So that will be kind of important, especially when we're doing the Explore Learning Gizmo. So if they are connected in series, the same amount of current will go through each part. And so what will be different with this is the voltage through the different devices, depending on like what's hooked up within the circuit, will depend on their internal resistance. So keeping in mind V equals I times R. So we're saying when things are connected in series, current stays the same. So if we're keeping current the same, if we look at our relationship between current, resistance, and voltage, if we know the voltage of it, what we can look for is current as the voltage. Oh no, I guess I'd be looking for voltage. If I know my current, I don't need to rearrange this. If I know my current, and I know the resistance of whatever is the resistor, whatever's hooked up in series there, I can actually calculate the voltage. So if current is staying the same, the voltage is based only on the resistance of whatever the current is passing through. The sum of the voltages across the devices equals the total voltage of this power supply, so of the cell battery. If one resistor stops working and prevents the flow of current, all the resistors will stop working. So I think more now it's actually hooked up in parallel than in series, but Christmas lights are often connected in series. So if you put Christmas lights around your Christmas tree, we've all had the one strand that doesn't light up. And so you actually don't know which of those bulbs is broken, is not allowing current through, because it's not like it's like bulb, light up, and then this one's dead, and then all the ones after it are dead. The whole string that's connected in series will be dead. So that's actually not the best. I think they do hook some Christmas lights up in parallel now, so you can just see which one is burnt out. But yeah, I have so many lights on my Christmas tree. If some are burnt out, that's okay. So again, if one light, or if one thing is burnt out or is not working within a series circuit, nothing will work in the series. And again, that's because of that single direction or single path that can be taken. So if that path is cut off, there will be no flow of current. So in order to calculate the total resistance in a series circuit, we use the following formula. I was smart enough this time to pull up my data booklet ahead of time. So 4 resistances connected in series. It won't even let me highlight anything, hey? Whoop. No, not a friend. So for resistances connected in series, the way that we figure out the total resistance of the circuit is just the sum of all of the individual component resistances. So you add whatever your resistance of item 1 is, plus your resistance of item 2, plus your resistance of item 3, however many you have. You might only have 1 or 2. It might not go up to beyond that, but you just simply add the resistances of all of the resistors within series. We'll see the same formula, well, not the same formula, but we'll see our parallel one is in here as well if I don't hop back to it. So the total resistance in a series circuit, we use the formula, is R total is equal to R1 plus R2 plus R3, R1 again, and so on. Weird. So this one, hopefully you have the diagram. I don't know why it's not showing up in here, but hopefully it showed up in yours. If not, we're just gonna draw it. Oh. Looks kind of weird. And so it tells us next to it the resistance of each of the resistors. So at 10, this is representing battery, a cell, a cell, a cell, a wire, a resistor, a wire, a resistor, a wire, a resistor, a wire. So I don't have switches, I don't have multiple connections or anything like that in this one. The resistance of this one is 20 ohms, and this side is 15 ohms. So looking at the resistance for this pretty straightforward little series, so we in total have 3 resistors connected in series. So our total is equal to the resistance of 1 plus the resistance of 2 plus the resistance of 3, since we just have 3. Let's draw it properly. Not quite. In total, the resistance for this series, oh, that looks bad, is 45 ohms. So parallel circuits, on to the next. So parallel circuits consist of a number of paths which connect one part of the circuit to another. So on this last one, yay. On this last one, oh, I scrolled down. I didn't need to, I see. We see that electrons, again, can flow like this. Boop, 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 boop. So they can't take multiple paths. They're just going to flow through this circuit back to the positive terminal. So our source of electrons being the negative terminal, and so on. But when we get to parallel, there's multiple different ways that they can move through. So the voltage along each branch is the same. So again, that will be important when we get going with the activity that you guys are going to do. So in series, again, we have the same amount of current going through each portion. The voltage in parallel circuits is the same. So the total current in the circuit is divided among the branches of the circuit. As the number of branches increases, the total resistance of the circuit decreases because there are more conducting paths, there are more ways for electrons to flow. So this decreases the total resistance. And if one resistor stops working, so if one bulb burns out and prevents the flow of current, the other resistors will still continue to work. Because again, there's multiple paths through. So in this one, if this resistor stopped working, well, we would no longer have a closed loop. So we wouldn't have any current running through it because we wouldn't have a closed loop. Whereas in a parallel circuit, there are other closed loops that can be used. So our total resistance in a parallel circuit is found using the formula. Sorry, this R kind of moved over from where it should live. So 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3, yada, 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 for however many resistors that you have connected in parallel. Whoa, stop. Jeez. Okay, so you probably don't have this one drawn in your book because I don't, but maybe I sorted it out when I printed it. Okay, so we have an artiste, I tell you guys. This is going quite well, we'll say. Uh-oh. That should have lined up way better. And it didn't. So I'm going to have a resistance of 8 ohms there, 8 ohms there, and the bottom one, it has a resistor of 4 ohms of resistance. Oop. Hopefully you can read that. Maybe, because you're just trying to figure out my drawing, I can rewrite it. 4 ohms of resistance. So again, the formula that we have up there, we have in total 3 resistors connected in parallel. Total. Again, that formula is in your data booklet, so I don't think that you need to remember that. So now just substituting in the values for our resistor. So 1 over our total is equal to 1 over 8 plus 1 over 8 plus 1 over 8, 1 over 4. Oops. So you can put it in your calculator and just convert it back to a fraction if you need to. So 1 over 8 plus 1 over 8, this would be 2 over 8. So in total, I get 4 over 8, which, you know, stresses me out because I would rather write it as 1 over 2. I'm not going to do that because I'm not a maniac. RT equals 1 over 2. So the thing is we haven't solved for what our total is. What we've done is we've solved for 1 over our total. So we've solved for 1 over the total resistance is equal to 1 over 2. So if you wanted to solve for this, you could do a cross multiply and divide. You could just flip both your fractions over. 2 over 1, which is equal to 2 ohms. So the total resistance of this, sorry, I'm waving my pen around it, of this parallel circuit is 2 ohms. And again, as the number of branches increases, the resistance of the circuit decreases. So you saw last time, we added it up and the overall resistance was the sum of all of those added together. This is a lower resistance than what these 3 resistances would be, and that's again because of the multiple paths that the electrons have to flow. So I'm just kind of peeking. Do we want to talk about... No, I think we'll do direct and alternating current next day because, or when we talk about motors and generators, because those are kind of important together and I don't want to get ahead of myself. So, I have something. I'm just going to write it down on the bottom. I don't have a textbook with me. I'm sorry, I have to write it up here. Oh, you might need the textbook CD. Yeah, I wrote need textbook CD and software, so that's not going to help. So I'm going to stop this video here and I'm going to make another video that's going to go through working through the application because it takes a little bit of time, and usually we do this in the computer lab together where we can all chat and you guys can ask questions. So what you need to do is search your email from me and find a password for it, and you need to bust out the sheet that says Explore Learning Gizmos. So the next video will kind of go through how to work through the application and what you need to do for the assignment. So I'll record that one and you can watch that one next.